We will start taking your questions first. Okay, now we are recording. So before we're going to start the description, if you've been here yesterday or if you already have a question with the G coding, go ahead. Do you have specific questions?
I wasn't here yesterday, so I don't have any right now.
And do you have anything on mind you want to ask me about it? Now, I would like to every one of you, we're just 5 here, so I would like you to rate from 1 to 5. How do you understand the G coding so far? G coding in general, not about the assignment.
It seems kind of straightforward. It's probably a 4.
Okay.
Yeah.
You guys? Johnny? Ting? Robert? Mohammed? What's your rating for your understanding for the G coding so far? I'll try to actually getting my external hard disk to get what? Yeah, guys. So what's your understanding for the thing? Good. Now, Robert, do you have brief experience with it? So I don't want to get all the credit if you already did that in another subject, or maybe you did it from the practical life. So I'm not going to be the one who take the credit in that case.
No, I don't. Just from the tutorials and your lectures.
That's great. Because actually, I usually feel happy if I see that my style of teaching is making a good result. Oh, by the way, do you know that this semester maybe is going to be the last semester we're having this subject? I don't know why, but it seems that it's not going to be run in autumn. They show us the plan today for the 2021 about the subject. And it seems they want to compress the subject to 17 subjects only, so they can squeeze the expenses on the teaching. I don't know how they're going to do that, but anyway, they removed this subject. They removed the air conditioning, and they removed what the other subject I was doing. I don't remember. So I don't know. We still have the material handling. I'm not sure if I'm going to run it. Usually, Terry Brown is the person who is the subject coordinator for this subject. So I'm sure that he will call me back because I was running the subject for the past 5 years. Okay, so let's go back once again to what we have now. As long as you think that you are good with the thing, the most important thing we are going to cover today is going to be the steps toward finalizing your section for the G coding. It's going to be quite lengthy, but we will try to make it as simple as possible. In the lecture last Monday, I talked about something called the route sheet, which is going to be description for the steps or the machining for the part. So we need to make this part, which is actually imaginary part. I don't think that we need something similar to that. It's more likely to be the key from Indiana Jones movie when he had to put these things inside the wall and turn on the thing. But that's why it came in my mind to be the most simple thing that the student can do with the manual G coding. The main challenge we're going to have for this process is going to be finding the location for the centers of these holes, as well as doing the profile cutting for the hexagonal shape. And I will tell you how it's going to be challenging. It's not very hard, but it's quite challenging. Now, shall I ask Johnny, why you are a guest? You are in our subject, right? Because here you are the only person who appeared as a guest.
One time I logged in from the website and I was a guest, so maybe.
Maybe. Anyway, that's not a big issue anyway. because I thought that this that's why I'm using actually the Teams more than the Zoom. I don't like the Zoom. Usually the quality of the Zoom is quite bad, and also they take a long time to processing the video, and from time to time they shut down the website, and you have to wait for your video for a whole week. In Teams, when we are going to finish the recording, everyone in the meeting will be able to be access to the videos, and this is the advantage with that. Besides, the security features for the Teams is much better than the Zoom. In the Zoom, anyone who has the code can access to the conference. And what's happened actually in the past 6 months, that some students were logging to the lecture. That's what's happened to one of my colleague, and he started to post improper thing. This one is impossible. Only people within the team are able to join the meetings. Okay, so what we're going to start with is the step-by-step process to finalize this shape. Give me ideas. Give me some ideas. How are we supposed to start to finish with this part? Now you can see that the dimension we have for the part is. Okay, so we have 40, this one is 70 plus B. So the maximum value is going to be 79. And we need to add this height and the other height. So how we can calculate this height? I mean, from this point to here. I will sketch something, and this will explain to you how the dimension can be calculated.
It's just some trigonometry, yeah.
Exactly. So the only thing we're going to do is use the simple theory of the triangles we learned from the high school. Okay, so what will be the value of the each angle we have in the hexagonal shape? What will be the value of this angle?
120.
Now we can simply cut that to triangle, and rectangular shape in the middle. So this one is going to have 360 degree plus a 360 degree, which is 180 degree for each triangle, and this will make it 720. Divide that by 60, you'll find what will be the angle, each angle we have in the hexagonal shape. Then if I'm going to make a perpendicular line here, this will be 90, and the rest is going to be whatever the value minus 90 degree. And first we'll be able to find this side, multiply the sine of this angle by the length of this side, we will find the vertical height. So I'm sketching something on my paper. I'm going to show you what will be the total height and where we are going to use it. Okay, so I will put the maximum value. Alpha, because this is how we are going to start with to find the value, the dimension of the original part we're going to start the machining of. Okay, so now this will be the shape. This one is 79 maximum, 70 minimum. The side here is 70. So to find the upright side is going to be 79 multiplied by the sine of this alpha. Okay. Of course, the alpha value is equal to 720 divided by 6 minus 90 degree. Okay, so from there we'll find the total height, and it's going to be the total width as well. Starting from here, we can do the first sketch, the first hand sketch, which is going to be for the stock material we're going to start our work at. Now, each side is going to be 70 plus B. I'm going to write 70 plus B. 70 plus B. Now, for the height, go back once again to the drawing. The height is going to be 10 millimeter plus A and plus 6 plus A divided by 3. Now, once again, I will consider that my A is equal to 9. So we have 19 plus 6 plus 9 divided by 3, which is 3. So we're going to have 19 plus 9 is going to be 27. So the total height of my block is going to be 27 millimeter. So this will be the first hand sketch we're going to have, which is going to be the stock material 70 plus B, 70 plus B, and 27 millimeter. That is clear? Is that correct or I'm wrong? If you're going to search online for a block material to start your machining at, you hardly to find 27. You'll find 20, 30, 40. Okay, so in this case, we're going to add 3 millimeters here, and the start out block is going to be equal to 30 millimeter height. But the height I would like to have at the end is going to be equal 27 millimeter. Okay, so at the beginning, we will say that use aluminum 610. That's the grade of the aluminum. Okay, block with the dimensions.
Is it the T6? I think SolidWorks.
610 block.
Okay.
Okay, this is CK at the end. Okay, I'm sorry for the hand written. Okay, so with the dimension of let's say I'm using the B and the A is 99, so it's going to be 79 times 79 times 30 millimeter. So each one is going to be a millimeter. So that's the dimension we're going to start the work at. Okay, and of course it's going to be much easier if you're going to say it's going to be 80, but that's the dimension we're going to deal with at the moment. Now, first thing we're going to do is we would like to take the thickness from 30 to 27. To do that, we need to do a face milling from both sides to remove 1.5 millimeter from each side. Okay, so what we're going to do, set up setup number 1. We are going to describe to the machinist how he's going to hold the part, what the cutting tool he's going to use, and what will be the process. Setup number 1, operation 1. Okay, setup number 1 is use vise to hold the part on milling table. Operation number 1 is going to be face milling of the bottom surface, or the face number 1 to the, or to remove 1.5 millimeter thickness. This will present the depth of the cut we would like to have. Okay, also you can say that use, let's say 30 millimeter diameter, diameter cutting tool. You can, of course, give the details of the cutting tool. For example, you will say that the HSS with 4 flutes. Of course, 4 flutes, that means it's going to have 4 teeth. And you can give an extra details about, for example, if you're using the catalog, about how many cubic millimeter per turn is going to move. Well, I think that will be enough. Okay. Now, I think this will be enough description for the operation number 1 in the setup number 1. Next step is going to be about sketching the tool path. You have 2 options in this operation. how to find out your datum point. You can see that this shape actually is going to be a symmetrical shape, right? If I'm going to cut it here, both sides are equal. The same thing if I'm going to cut it here, both sides are equal. So I can simply use the center to be my datum point. Once again, I'm just adjusting. If you would like to use this point as a datum point, and then you can simply find the location of every point accordingly, it's up to you. This is a suggestion to have this datum point, or I can have it here. This is going to be helpful just in case when we are going to do the calculation for the location of the holes around the part. However, for this one, in my case, I'm going to use the datum point as the center here. I'm going to divide the part into a multiple area. We said that the total thing is going to be 79 and approximately is going to be 80. So I'm going to do my finding the location for the part. So I divide thing by 20 by having 30 millimeter cutting tool. So 80. So I can divide this one to 3 sections. So here is going to be, for example, 25 and 25. This will be 50 and 25 and another 25. And extending this line upwards. Okay, so this one is 25, 25, that's 50. We should have 40. Actually, this will be passing further. The lines will be here. Okay, this will be approximating. Doesn't matter. Maybe it's going to be within. Now I'm going to find the location of these points because that's where the cutting tool is going to move between to do the work. Okay. Now just remember that this is my 0 point. So everything above that is going to be positive y. Anything in this direction is going to be positive x. The other way is going to be negative x. And this direction is going to be negative y. So in that case, if the total height here is 79, that means this will be 79 pi divided by 2, which is 39.5, negative 39.5. The same thing will be for the x-axis. Now, I need to hear your suggestion about what will be the location of that point in this case. Obviously, the y is negative 39.5. What about the x?
It's a little bit less, isn't it?
It should be a little bit more. Actually, no, because I said that the distance between these lines is 25 millimeters. So this will be negative 50. I told you that this one, I just made it before I thought about it. So actually, this will be a little bit out. So what's happening is that my cutting tool is going to move and clean the material by the movement of the forward and backward. It will overlap over the actual area it has been cut before. Okay, now if this one is confused you, I'm going to sketch a new one. You got the description, right? Do you would like to see it again before I get to move? Describe the setup, how we are going to hold the part. And then the first operation, face milling of the face number 1 to remove 1.5 millimeter thickness. The tool is going to be 30 millimeter diameter cutting tool. And we're going to have a high-speed steel cutting tool with 4 flutes, which mean 4 teeth anyway. And once again, I'm going to sketch that, and this time I will try to be more accurate with the shape. Okay, now once again, this is the length, the actual length, the actual length is 79.5. I'm using the maximum value where the x is equal to the A is equal to 9 and the B is equal to 9. So 79. So by dividing the things in the middle, okay, so this point, this point, this point, and that point is going to be, this will be, we're moving to the positive x-axis by 39.5. So this point is 39.5 and 39.5. Both x and y are positive. Below here, the x remain positive, 39.5, but the y is going to be negative, not negative 39.5. In this direction, both are going to be negative, negative 39.5 and negative 39.5. What do we have here? Oh, where's everyone? They all disappeared.
It's negative 39.5 and 39.5.
Exactly. Negative 39.5 and 39.5. Okay, and here we are going to have, here the x is 0, but we have negative 39.5. Here the x is 0 and 39.5. And of course, I can cut this one in the middle. So we're going to have the thing divided by 2. So now my cutting tool is going to move between this point to that point, to this point, down, to the right, up, to the right, down, to the right, up, done. I remove the whole top surface to a depth of minus 0.15, 1.5 millimeters. So to find this one, actually is going to be very easy. The y is not changing, the x is divided by 2, the same thing here, but this will be positive value. The same thing happening to here, so the x value will be divided by 2 in this location. And the same thing here. So I can number the points as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this will be your handy sketch. It doesn't have to be fancy thing. We're only going to use this one to find the points location. And you can simply, if you want, you can write down the points location here from 1 to 10. Okay, and then you can write down the G code for this operation. The G code for this operation is going to be, of course, at the beginning, you have to put the N10, which is in line number 1. Then you will write down that this will be M06 and the tool number 1, which is the 30 millimeter diameter. And let's say we are going to use the G20, which is the millimeters, and the G40, I forgot the name, maybe it's 42 for the absolute dimensioning. Then N20 is going to be M03. We started the spindle, and we have to define what will be the RPM value. So let's say it's going to be 560. I don't remember that. This is S, and this is a number. Then N30, G00 to the X is equal to minus 39.5, which is point number 1. And the Y is equal to minus 39.5. And the Z is equal to 10 millimeters. Or simply, I will write down that here as a note, go to point 2, go to point 1. So actually the center of my cutting tool, the center of the cutting tool, okay, will be above the first point, but with the height of 10 millimeters. It's not, I cannot simply do the things diagonally. I should go to the top, then going down. Okay, so this will be line number 1. Line number 40, sorry, is going to be G01. The X and the Y not changing. The Z is going to be changed to the negative 1.5. That's point number 1 still. Okay, now my cutting tool is rotating beneath the surface by 1.5 millimeter. And 50 GO, I can simply skip writing down the GO, but GO, go to the X is equal to negative 39. They're not going to be changed, so I don't have to write it down. Go to the Y is equal to 39.5. Oh, I forgot to write down something here. The feed rate, which can be 300 millimeter per minute. I can increase the feed rate or I can keep it the same. So my cutting tool is now moved from this location to that location. Then going to the right. So N60 is going to be the X is equal to negative 39 divided by 2. So it's going to be 19.25. Negative 19.25. Okay, and the Y remain the same. And 70 is going to the Y, negative 39.5. And 80 is going to go to the X, equal to 0. Okay, then N90 is going to go to the Y, 39.5. And 100 is going to be go to the X equal to 19.25. And 120 is go to the Y, negative 39.5. And 130 is going to go to the X equal to 39.5. And the N140 is going to be go to the Y equal to 39.5. Then the N150 is G00, Z equal to 10. And then the last, that's 50. And the last two lines are going to be about take off the cutting tool away, 10 of the machine, which is going to be the M00, and that's it. Is it clear so far? With this operation, we just removed.
Yeah, is there a reason why you didn't use N100?
Sorry?
Is there a reason why you didn't use N100?
M00, you mean?
No, like N90 and then N110. So there's no N100.
Oh, yeah, well, I missed that.
I missed that? Okay.
I missed that, yeah. Doesn't matter. It's happening even when you do the programming. That's why actually we do it by 10 so we can insert something. I missed that. I just adding a number, but the machine is going to read by the logical sequence. So for example, if I'm going to put the N85 after the N90, the machine will have an error. Okay, but if I'm going to put N90 then N99, it will read normally. Okay, so that's what we are going to have for the operation number 1 in the setup number 1. Now the good news is the same code will be repeated for the operation number 1 in the setup number 2.
I've got a question about the spindle. You just want to keep the spindle going, do you? In between, you're not going to stop the spindle.
Yeah, you need to start the spindle. Another line should be written here. You need to move the cutting tool away first.
Yeah.
Take it to somewhere in the negative direction. For example, it's going to go to the negative 100 and negative 100 for the X and the Y. Then turn off the machine, so you can take off the part.
Yeah. Okay.
Okay. Then you do the M00, which is turn off the machine, and that's it.
Yeah. Is it okay using the GOO, the full speed command, to just move away from the part, or would you sometimes just move away slowly from the part?
It's up to you. It doesn't matter.
Yeah.
Okay.
Yep.
Now, that's the first operation with the first setup. Just remember that when we say using the vice, go back to the same original shape. So the vice is going to holding the part from the side. Okay. and another one on the other side, so we can do all the machining from the top. And that's what we keep doing it. Usually when you hold the device, you are going to have a space below it. So you don't have to worry even when you do the drilling, because the cutting tool is not going to go through and cut the table. But when you do the profile cutting, you need to add a layer, pad layer below to protect the table. We're going to talk about this one in the next stages. Now, the same code, if it's up to you, if you're going to type it, then you can copy and paste it to the operation number 1 in the setup number 2. So let's see what we'll have on the next page. Now, just remember, we just reduced the thickness of the part from 30 millimeter to 28.5. We removed 1.5 millimeter.
So is that your rough cut that you're making?
Yeah, well, it's up to you to make it rough cut or finishing cut. Well, because we didn't talk anything about the quality of the service we would like to have at the end, right? I don't want you to extend the work on yourself by saying, well, actually 1.5 can be done as a finishing cut, by the way. The finishing cut for the aluminum can be anything between 2 millimeter and below.
Yeah, okay.
Okay, but we're just removing the material. So now,
did the machine sort of forget? Did they forget the feed rate once you put the command GOO in, or does it sort of remember the feed rate, or is it just
the feed rate?
To always put in?
Whatever you write down as a feed rate,
yeah.
If you haven't changed it, I mean this one. If you haven't changed it, the machine keep using the same value.
Yeah.
Okay. So now the step we are going to make is, let's say this will be, we can say step, I don't want to go setup, but anyway, after the process, you can write it on the other side. Take the part to the inspection table. This will be nice to do it between every setup. Put the part on the table, inspect it. Maybe you cut it an extra dimension, or maybe there are some flows, which is some material taken off due to the wrong cutting tool thing, and we're going to have a small hole. It's happened. Okay, then you're going to do the setup 2. Now, once again, flip the part to face 2, and then remove. Use the vise to hold the part on the milling table. Okay. Now the operation 1. Now, why operation 1? Because it's setup number 2, operation number 1. Use 30 millimeter diameter high-speed steel cutting tool to remove 1.5 millimeter thickness layer from face 2. Now I'm using 1.5 each time, so this will take it from 30 millimeter thickness to 27. Now it's 28.5 after removing the 1.5 from the first face. I flip it. I'm going to remove another 1.5, so the thickness is going to be 27, which is the A plus 10 plus A plus 6 plus A divided by 3. So I don't want to sketch a thing. I can simply bring the same sketch, the same old sketch, and we're going to put it here. Okay, the same code will be copied, and we're going to put it here. Okay, and they're finishing the first operation in the setup number 2. So I can write down same sketch and code for operation 1 setup 1. If you do that by typing, copy and paste. Just copy and paste. Okay, now you'll ask me, okay, now what about the height? Is it going to be different? No, because when this is a vice, so it's up to you to put it up or down. So the height always of the top surface is going to be the 0 level. Operation 2. Now the same setup, operation 2. Now in the operation 2, we would like to get something like that. Now the block is going to be, the new height is going to be equal to a 10 plus a. And in the middle, again, to have a square shape, which have the height of the 6 plus a divided by 3. That's what we would like to have after finishing the operation number 2. From the top, in the 2 dimensions, it will look like that. Square shape. And I always try to find the center.
So this is operation 2 in setup number 2.
Yes.
Yeah. Okay.
Okay. Just remember that the dimension of this square are going to be shown in the engineering drawings. I think it's going to be 40 plus a. So it's going to be, obviously, if this one is 79, this one is going to be 49. Okay, if this one is 79, this one is going to be 49. So here we are going to have face milling, but around this part is going to have a profile. So to make the profile, do I have to use the same cutting tool? I'm going to use a 12 millimeter cutting tool now. Okay, I was going to describe that here, but I'm going to use a 12 millimeter cutting tool, so I can make an offset line parallel to the square shape. They are offset by 6 millimeter from the original line. Same thing here. Okay, so I can find these points. Now my cutting tool is going to move along these points. So just remember, that's not going to, the side of the cutting tool will pass through this one to do the profile cutting, but it's not going to go through it. Okay, we're just going to move it between these points, removing the material. Then we can go for a bigger square, then the bigger one to clean the whole thing to the depth of 6 plus a divided by 3. Now it's up to you to consider that this is the datum point here, or you can put it at the height of 1.5 millimeter. I'm not going to actually mark you against that. If you are going to put the new height here, is going to be 6 plus a divided by 3 plus 1.5 in the negative direction, or you're only going to use this one. I'm not going to consider that as a mistake. Now, once again, this is 0, 0 point. Then I can find the location of these 4 points. Now, we said that this one is 49. Can you please tell me what will be the location of these 4 points? Do your calculation on your paper and give me an answer.
What was the size of the inner square that you wanted to
The inner square is 49 by 49. And I said that the offset of this line is 6 millimeter.
So they're all 30.5s, negative and positive, depending on which quadrant.
Okay, that's good. Okay, so we found the location of these 4 points. Okay, guys, what about you? Have you got the idea? Ting, have you got the idea? Robert, well, have you got the idea of what we're doing here, right here?
Yeah.
Now, this is time to ask a question. So just ask as much question as you want.
So it's offset by half of the diameter, right?
Half diameter of the cutting tool. So if I get to offset by the half diameter of the cutting tool, we are going to be sure that the side of the cutting tool is going to be in contact with the wall of the square in the middle. We're not going to go over it. Okay. Okay. Now the other thing is finding these 4 points. Now we want to extend the thing a little bit further to have the extra removal of the material. So as you can see, we're going to sketch another path where it's going to be moving in this direction. So a new 4 points. These 4 points are going to be offsetted by 5 millimeter. Now, why 5 millimeter, no 6? Because I would like to have the cut. For example, the first cut has cut it anything between these 2 lines. Usually, we don't do the other cut, and this is the tool path. Okay, so usually we don't make the other tool path, and the new cut is going to have the same width. We usually overlap it a little bit. This will prevent having the sharp edge between the 2 cuts. So we are going to reduce the extra process to, for example, remove the burrs from the cutting. Okay, so very easy to find the next point. If I know this one, I will go up by 5, and then I shift little bit by 5. This will give me a location of this point. Because it's square, I can find the location of the other point, the other point, and the other point. Now just remember, once again, this is not up to scales. We keep doing the squares, one over larger than the other, until the last one is going to be more than the 39.5 in location. You got that? So again, to because actually this rectangular not square, so it's something like okay. So this is the 40 by. Someone said something. Can you please repeat this step? Yes. Yes, sure. Okay. So I would like to cut all the material between this square, which is 49 by 49, and the larger one, which is going to be 79 and 79. Okay, so to achieve that, my first tool path is going to be around the original square. Again, to put the points on that. Okay, so at the beginning, we're going to move from 1 to 2 to 3 to 4 to 1. Okay, so we're removing everything around the part by the width of 12 millimeters. Then from here, I need to move to a new location, which is going to be this larger square.
Why did you cut the center square shape out first rather than starting at the outside and moving in?
Okay, this will make it much easier for you to start from the inside to the outside when you do the manual G coding. So you're not going to start at the end and you cut the square by mistake.
Yeah, so also the machine might do the operation the other way from the outside to the inside.
It can.
Yeah.
It can. You can start from the outside.
This is just like for planning purposes and keeping it easy as possible. Yeah.
I just want you to find the location in easier method. Square, the small square first, then you enlarge it, do the second larger. So it's going to be something like doing the pocketing.
And then just enlarge it with a bit of an overlap to avoid
exactly.
Yeah, okay.
Until you're going to finish at the end by moving at these points. I think we're going to need in total, well, this side is going to be 70, so 30, that's 15 by 15. So we need to do it in 3 squares. I'm sure about that. We're going to have 1, 2, and 3. 3 squares, and you are going to finish the cut. Now, I numbered that 1 to 4. This will be 5, 6, 7, 8. Then go back to 5. Then this will be 9, 10, 11, 12. So simply, we're going to write down the G code. And of course, you have to mention here is profile cutting around the square in the middle using the cutting tool with the diameter of 12 millimeter. That's the description of the operation. The G code, I can simplify that to you. G00 to the point number 1. And then G01 to the Z equal to, of course, the Z here was 10 at the beginning. Okay, to the Z equal to minus 6. If you want to do it in one shot, or you can do it in multiple stages. So the first depth is going to be equal to minus 4 millimeter, for example. Okay, then you write down the code G01. You have to add the feed rate, by the way. Okay, G01 to 0.2, G01 to 0.3, G01 to 0.4, G01 0.1. We need to go back. Otherwise, we're not going to have removing of this material. G01 to 0.5, 0.6, 0.7, 0.8, 0.5. Then from 0.5 to 0.9, 0.10, 0.11, 12, and then 0.9, done. Now, this was to the depth of minus 4. Then we can go back the opposite way, or you can take the cutting tool to this location once again, copy paste the same code, just change the Z value to be negative 6, or that's for make it, 6 plus A over 3. Just copy the same code and put it down. When you finish, you take the cutting tool to the height of 10 millimeter, push it away, and turn off the machine. Rajith, do you have any question about the code? Now, when I write it P's, now I consider that you will find the X and Y of each location here and put it here, G01, X and Y, X and Y, and so on.
And do we need to inspect as well again?
Sorry?
Do we need to inspect it?
Oh, yeah, of course. No, because we're still under the setup, so don't inspect it now. We still have to do another operation, which is cutting the slot and drilling the holes in the same setup. We didn't remove the machine, the part from the machine yet. You don't have to take it out and inspect it each time. Okay. So once again, you may copy the same code and put it multiple times. Just change the thickness, and that's what we call decanning. We're just repeating the same code to cut a multiple level. Okay. Now, the operation number 3. Do I have to write down a brief description of this operation, or you already understand that?
I don't get why you're plunging down into the part at point number 1 instead of coming in from the side onto the part.
Yeah, so we call it profile cutting around the square of dimension of whatever thing is 49 by 49 in my case. You can say it's 40 or 41 or whatever.
It surprised me that the G01.
Yep.
If that's at point 1, that's like boring straight into the part first and then moving sideways. I would have come in from the side on the part for the whole thing.
You want to come from the outside to the inside?
Yeah,
it's up to you.
The inside.
Well, when you are going to find the location of the point, then it's up to you to start from 9, 9, 10, 11, 12, 9. Then you go to 5, get it smaller until you are going to go around this one. Okay? Yeah. Now, operation number 3. So, operation 3. Now, let's inspect the part before we're going to change any tool and see what will be the next operation I can make. Cutting all the slot will require a new cutting tool, which is going to have a 6 millimeter diameter thickness, diameter, sorry, as you can see here, because the thickness, the width is 6 millimeter. So I'm not going to cut the slot now. I either going to do drilling of the holes or the cut of this arc. So which one you want me to do first? What do you suggest?
The arc.
Take this one arc. Okay. So set up operation number 3 is cut the 2 arcs at the face of the top square. Use 12, because this is the same tool we used earlier, 12 millimeter diameter high speed steel cutting tool. Okay, sorry. Okay, so this will be the description of the operation. Now show that graphically. Graphically, what we're going to have is the same square from previous operation. I know that we have to do the same sketch multiple times. Okay, and we're going to have the center in the middle. And I'm going to make my square shape. Okay, and now I can find the, you remember that if you're going to check that, you can see that the arc is extended from the center of the line to the other center of the line. Well, actually, it should be this way. Anyway, it's going to be the same thing at the end. If I get to turn that way. Okay. Okay, so now we know these points, but it's not going to be the useful one for us. The useful one for us is again to sketch another arc, which is going to be smaller by 6 millimeter. So what is the radius of the bigger arc? It's going to be half of this length. So if this one is 49, so the radius of the arc is 49 divided by 2, which is going to be equal to 24.5. But the R I'm going to use for my G coding, R of the cut is going to be equal to 49 divided by 2 minus 6 millimeters. I'm going to use this one in the coding of the G02 or G03. From here, I can find what are the location of these points. By logic, Okay, this is 0. Okay, and this will be well, I should maybe I get to sketch another one because I don't like to explain it like that. Otherwise, the student may get confused. Anyway, well, yes, this will be the positive y. This will be the positive x. And to find the location, for example, of that point, this one is going 24.5 to the positive and going up by the value of 6 millimeter. So this point was going to be number 1. The coordination is going to be equal to 24.5 and 6 for the y. For this point, it's going to be 0.2. For the x is 6 and the y is 24.5. For this one is going to be a negative value, the 0.3 and 0.4. So in this case, 0.3 is going to be equal to negative 6 and negative 24.5. And for the point number 4 is going to be equal to negative 24.5 and minus 6. So I got these 4 points, and then I can write down my code for this operation. The depth of the cut was 3 plus b over 5. So it's going to be almost 3.5. Let's say it's going to be 3.5 if the b is equal to 9. So the code is going to be very simple. Once again, we need to write down the first N10 and N20 from the first line we use for the face milling. But just remember that this will be the tool number 2. And then we start this spindle M03 with the spindle speed of 600, for example. The N30 is going to be G00 at the top of the point number 1. So the X is equal to 24.5. The Y is equal to 6. The Z is equal to 10. Then the N40 is G01 to the Z equal to minus 3.5 with the F of 300, for example. Then the N50 is going to be G0. Now, if we are going to move in this direction, that's going to be clockwise or counterclockwise? From 1 to 2.
G02, yeah.
G02. So G02, and we have to define the X and the Y of the next point. So the X is going to be equal to 6, and the Y is 24.5, and the R is going to be equal to the radius of this one is 24.5 minus 6, which is 24.5 minus 6, which is equal to 18.5. So the R is 18.5. Done. We cutted the first arc. Then we go to the N60, G00 to the Z of 10 millimeters. The next one, N60, N70, G00 to the next location where the X is equal to the P3. X is equal to minus 6, and the Y is equal to minus 24.5. Okay, and then we are going to go once again the N80, G01 to the Z of minus 3.5 with the feed rate of 300. Then we can repeat the same thing. We're going from here to here. That's it. And 90, G03, because you're going counterclockwise to the next point where the X is equal to minus 24.5, and the y is equal to -6, and the r is 18.5. Then the last point, and 11 and 100, sorry, G00 to the Z of 10 millimeter, then 10 of the machine, and 110 G00 to -100 X -100 and Y -100. Okay, then 10 of the machine. That's the code for the whole operation. We're done with that. Now, the next operation is going to be drilling the holes. Now, I do it by 10 of the machine after each operation because I don't want to mix the whole code together. In real life, if you would like to make the same part, you will need to connect the whole G code together. You're not going to set up a new G code each time. Unless if your machine is not current machine, that means you need to stop it and you need to change the tool manually. Then you do the M00 at the end of each code. Operation number 4. Operation number 4 and the setup number 1 is going to be drilling the holes. And that's not going to be done before after the slot cutting, because in the slot cutting we need to change the tool. So I'm going to drill the holes, then change the tool to cut the slots. But the process of calculating the location of the hole diameter centers, once again we're going to use a triangle to do that. Now my triangle is going to be starting from here, ending to here, then going down. This will be the first triangle. The second triangle is going to be finding the distance between these two lines. This will be very easy actually to be done. Find its center. Then I'm going to may have another triangle. Find the height of this point. Now, how to find location of this one? I can find the length of this line. That's going to be very easy because I know what this distance is. And also, I can find the angle of this chord. Finding its length, and I know what the distance from this center to the outer wall of the slot. It's going to be 102 plus B. Subtract these two lines, the long one minus this short one. I will find the distance from this corner to the circumference of the circle. Divided by 2, I will find what the location of this one. Again, to do that graphically on the paper. Actually, I just made that as a challenge. I didn't set out the location of this one because I would like you to practice the manual calculation for the triangles. Okay, so and actually by finding one of them, we can find all the other points directly. So I'm going to sketch that by hand first. So what we have is 70 plus B, and actually it's going to be 79 times 2 is 158. I just do show you some calculations before I get to show you the drawing. Okay. So to find the center of the point, we're going to make this triangle. This is the 0, 0 point. The distance from here to here is 158 divided by 2. which is 79, obviously. How did I got this 158 times 2? Because you remember that the total height of the total height from this point to that point is equal to 79, because my b is 9. 79 times 2. Now why times 2? Because this angle by calculation is going to be 30 degrees, and the sine of 30 degrees is 0.5. That means this height from this point to that point is going to be equal to 79 times 0.5. So we have half of 79, half of 79, and 79. So it's going to be 2 times 79. So the distance from this center to that wall is going to be equal to 79 as well. Now I know what the angle here, 79, and this height is 79 divided by 2. I can find this angle. And as I shown in the drawing, the distance till here is 111. And the center of my triangle is going to be in the middle between this point and that point, exactly in the middle. The 111 is the radius. Oh, that's divided by 2. The radius of the outer circle, which is 102 plus b, which is 9 divided by 2. So I can find this length. Okay, I can find this length. Subtract, we will have this length. Divided by 2, we will have this length. Then I can make another triangle, knowing the angle, knowing this length, multiplied by the sine of this angle, we will find this height. So tick, I find the value of this point, which is going to be the center of this hole. Now, of course, this will be in negative value. Then I can find this one is going to be the same value, but in positive x. This one is going to be negative x, negative y. This will be negative x, positive x, negative y. And this one, negative x and negative y. For this point, if I know what the length between this center and this center is going to be the same height of these 2 points. The x-axis is going to be equal to 0. Okay, so I found the points where the centers location are, and I can write down my G code for it. To sketch the part, just remember that the part is still square shape. I didn't cut it yet. I can make the hexagonal shape within it. Sorry. Seems that I don't know what I'm doing right now. Okay, sorry. Again, to repeat it, it's became too ugly. Maybe 2 lines aside. Make a middle line in the middle. Okay, so this is my hexagonal shape, but actually is still lying within the square shape that we haven't cut it yet. Okay, so we found the location of the points here, which represent the center of the holes we are going to have. We found the x and the y of each one, and then my tool path is going to be as following. Just attach between them. Now that means it's coming from here, going to the top of this one, do the drilling going up. And as I told you in the CAD CAM, we should follow a sequence after either clockwise or counterclockwise. So for example, this will be the point number 1, point number 2, point number 3, point number 4, point number 5, and point number 6. And this is the start point. It's not specified, but we can do it later. So this was the operation number 4. Drill 6 holes through with 12 millimeter diameter. Okay, of course, using the 12 millimeter diameter cutting tool. That's the description of the operation, and we are going to write down the G code for it. Now, the M10 is the definition of the thing. The M20 is M03 and start the spindle. M30 is G00 to the X and Y of 0.1 with the Z of 10 millimeter. M40 is G01 to the Z of minus. Now, what's the total height was? Okay, so we're going to the bottom here. So the height is going to be equal to 10 plus A plus 6 plus A over 3, which was 27. Okay, so Z is equal to minus 27. Then the M50 is going to be G00 to the Z equal to 10. M60 is going to be G01 to the point number 2. And of course, the height is still 10. M70, M70 is G01 to the Z of minus 27. M80 is G00 to the Z of 10. So we keep doing that until we are going to finish the whole drilling operation. And when we're done at the point number 6, we go to the Z equal to 10. Then we go to the start point, which can be the minus 100 and minus 100.
We got a is there a tool change before we do drilling that we need to?
No, the same cutting tool, the 12 millimeter. Why do I need to change it?
All right. And then we never stopped the spindle the whole way. We just kept it spinning. So we didn't put in a new. Oh no, I see it. There's your spindle speed.
Yep. So the only process we're going to make in drilling, we go to the top of the work, we drill, we go up. Moving to the next one, we drill, we go up. Drill, go up, and so on. So just something like when we do the tapping. Oops. Just doing the tapping during the movement. When we finish that, we traveling to the start point and turn off the machine, because we will need to change the tool for the next operation with the 6 millimeter diameter cutting tool. Okay. And also you can do actually the slot cutting with the next setup, but we can do it now. It's already fixed on the table, so just change the tool and finalize the cutting. So this will be the operation number 5. Cut the circular slot. 6 millimeter width. Using the 6 millimeter diameter high speed steel cutting tool. That's the description. Now this sketch is going to look like the following. So once again, we are not going to consider a lot. This will be the shape. Make a circle in the middle. Offset this circle by 6 millimeter to the inside. The outer one is 102 plus B. The inner one is 92 plus B. Okay, this is my center. Make a line here. Now, of course, I know the distance from here to here, and I know the distance from here to here, which is the radius of the two circles. I'm going to choose a point in the middle. Its y value is equal to 0. Its x value is equal to. So this will be point number 1, point 1. And the other side is going to be point 2. Now, the point 1 is going to be, the y value is 0, but the x value is going to be equal to, by calculation, I'm going to show you that by calculation, is 102 plus B minus 3. That's divided by 2 minus 3. But it's going to be in negative. So for example, it's going to be 111 divided by 2, and this will make it 55.5 minus the 3, 52.5 minus 52.5. Now, are you catching up with what I'm doing in my calculation? I'm going to explain that again. Now, the distance from here to here is equal to 102 plus B. So we said that the B is equal, divided by 2. Divided by 2. Okay, because the total diameter is 102 divided by plus B. So this one is divided by 2. Distance from here to here is going to be less by 3 millimeters. Because the total width is 6. So the middle is going to be 3. I hope that I'm not misleading you somewhere. So I'm going to ask you one by one.
Yeah, that makes sense, except maybe plus 3 for your calculation. So 102 plus B over 2 in the negative, and then plus 3 to the right.
Exactly, yes. Yep.
So just a little change on the note there.
Yep. So this one is going to be negative 52.5 for the x, but for the y is going to be equal to 0. The point 2 is going to be positive value, the same value, but positive, 52.5 and 0. Now, the only thing we have to do is write down a code, bring in the cutting tool at the top of the point number 1, take it down to the depth of 3 plus A divided by 5 plus this depth. Because we referencing from this height to lower level. So everything is referenced from this height. So 6 plus A divided by 3 plus 3 plus A divided by 5. And all going to be in negative. That will be depth of the slot from the top level. Okay, so the code is going to be as following. Of course, I'm going to skip the first 2 lines, go to the N30, G00 to the X equal to negative 52.5. The Y is 0, the Z is 10, then N40 is going to be G01, the same X and the Y, the Z is going to be equal to 6 plus 3, that's 9, and we have A divided by 5 is, let's say, is going to be 2. And we have, sorry, I cannot remember this because A divided by 5, let's say, is going to be 9 divided by 5, which is 2. and this one a divided by 3, which is going to be 3. So we are going to have 6, 9, 14, minus 14. Okay, so depth is going to be minus 14 millimeter with the feed rate of 280, for example. And then the N50 is going to be G02. I will go that way. The toolpath is going to be the hash line in between the two circles. Now do it by hand. I don't want you to make a perfect thing. This thing will do the work. G02 to the X is equal to 52.5 and the Y is equal to 0. Then the N60, G02, going back to the same point, minus 52.5, and the Y is equal to 0. Do I miss something here?
Yes, the R.
The odds, okay? And the R is going to be equal to what we have as a distant form here, which is going to be that. The R is going to be equal to 52.5. Okay, and the last movement is going to be G00 to the Z of 10. Then you can go to the G00 to the X minus 100, Y minus 100, and turn off the machine.
Did we assume the new face is the face that we're cutting into, because we've got a bit of the part sticking up above Z equals to 0, don't we? Like the block.
Yeah, we removed 1.5 millimeter. I told you earlier that if you are going to skip that, like what I did right now, this will be okay. If you are going to consider that and adding 1.5 millimeter here, this will be great.
Yeah, that's what I'm not quite understanding is when you change the datum for the Z, when do you change that, and what face do you change it to, and should you be careful if there's a part that's like there's a bit of the block in the middle is sticking up much higher than the datum?
Yeah, it's going to be actually just 1.5 millimeter that I ignored now in my most of the code I've done. If you're going, as I told you earlier, if you're going to do it, this will be great. Okay, but I'm not going to take mark if you just did like what I'm done for short cutting.
Oh, okay. So yeah.
So
okay,
actually, you can add 1.5 millimeter for all the Z values I used earlier. So this one is going to be negative 15.5 instead of minus 14. For the drilling, you are going to have minus 28.5.
Yeah.
Instead of minus 27. Okay, now what's the last operation we need to do?
And between the operations, we don't need to say the absolute dimensioning of the other one, right? It's all saved?
It's all saved, yeah. Okay, well, by the way, all the machine by default are coming, well, all over the world are coming with the units of the millimeters and with the absolute dimensioning, unless if you are going to set up the M92, which is going to take it to the incremental, and the G21 to take it to the inches. So by default, all the machines are using millimeters and absolute dimensioning. Okay, so now what is last operation is cutting the hexagonal shape. Now, to make your life easier, I don't want you to remove the material and achieve the hexagonal shape. I'm only going to ask you to do the profile cutting for the last dimension of the hexagonal shape. Now, of course, we don't have anything to do with the setup number 2. So the now take off the part. from the device. And take it to the inspection table. Then you do the setup 3. Now, setup number 3, I would like to cut profile cutting. Device will be damaging the cutting tool if I get to keep it, because I need to cut around the part. So to do that, the setup number 3 is use 3 of the pre-drilled holes to hold the part to the milling table using the bolts and nuts. You know, there are a special one, by the way. Okay, bolts and nuts. We said to protect the table, put a 3 millimeter thickness protection pad. To protect the table. Now, usually what the people doing in the workshop, they either using the plywood with 3 millimeter thickness, or they're using a rubber. But usually I don't like the rubber, because when you tighten it up, it's going to be compressed. And this may give you an error when you do the machining. So let's say it's going to be a plywood, 3 millimeter thickness plywood. I just name it as a protection pad. You can use whatever you want to have. Now, the operation in this case is going to be tricky, but not hard. The operation number 1 in the setup number 3 is, we said that we're removing the material. I don't want you to explain this one. Just do the profile cut of the hexagonal shape for a finish cutting to remove the remained, let's say 1.5 millimeter material. So what we consider is that we did the machining, we removed everything around the hexagonal shape, and we only had 1.5 millimeter material left. We are going to do the final cut for the finish cutting as the operation number 1. Now, the trick is going to be as following. I explained that yesterday, and I'm going to repeat it again. And actually, I'm going to sketch the sides. I'm going to tell you where we are going to have the trick in this operation. Okay, now that's the shape. Now, by now, we know the location of the points around. And what we're going to do is I'm going to sketch a line. Oh, we use the same 12 millimeter diameter thickness diameter tool. So we make a line which is going to be offset by 6 millimeter and have the intersection lines here. This will be my toolpath. The trick we're going to have with the toolpath is when I'm going to find these points, just remember that these points is going to be in this direction, not horizontally. So we need to do a simple calculation to find the location of that point. It's going to be offsetted by a certain value below this level. So let's try to find out what is the offset we're going to have here. I'm going to emphasize the size of this one to here. So this is the vertical edge, and this is an inclined edge. And the lines I have will look like that. So you can see they are not on the same level. You see, they are not on the same level. And actually, this value is going to be very important to be found. Actually, I think that this one should go wider, and it will look like that. So if I get to sketch a line from the center, passing through this line, coming to here, we need to find this distance. Now we can see a triangle. Again, to sketch another line which is perpendicular to this one, and this line is perpendicular to the other one. Okay, we have 90 degree, 90 degree, and this line is passing it through. I need to find this angle. We know that this angle is already being given, which is equal to 720 divided by 6. How can I find this angle? So what is 720 divided by 6? Let me check it with the calculator. 720 divided by 6. So the angle is 120. Okay, so this angle is 120. This one is 90. This one is 90. And then I can find the angle between these two lines. Now, let me sketch it back once again as a bigger shape. Okay, so I would like to find this distance. So again, we would like to find this angle. This one is 90. This one is 90. This is alpha. And this is 120 degree. And definitely the alpha, 2 alpha is going to be equal to 360 minus 120 plus 180. Then I can find the value of the alpha. I'm going to have this triangular shape. For that shape, I know the alpha, and I know this one is 6 millimeter. Then I can find this one, and then I get to compensate it. So we always get to go lower than this point by this value. Okay, same thing will be happening here. This one is going to be higher. This will be higher, but this one is going to be just above the thing exactly. And it's going to be within 6 millimeter diameter difference. Find the point. Now bring the cutting tool. The G code is going to be come to the top of this one, drill it down to the total depth, which is minus 27 or minus 28.5. It's up to you. Then start to do the drilling, giving the operation by moving to this point, G01, 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 then G00, and leave. That's the only thing we need to do for the operation number 1, setup number 3. Okay, so I'm going to keep this one, and you can do the same calculation. Just remember that the offset I had is 6 millimeter from all the side, which is equal to the radius of the cutting tool I'm using. Okay, done. That's all what we need to do for the G-code part.
Just a question about the depth that you go down to. Do you just go a little bit beyond the depth when you're face milling, or do you go exactly?
No, we left it as it is because that's what we meant to go. We just left the pad for the production for the table. We don't want to cut the table if a mistake happen.
Yeah.
Okay. So we consider that it will go to totally to the required depth, and it's going to do the job.
Okay.
Okay. I'm going to send also some updates regarding the CAD-CAM. I made the tutorial, but I said the thing orally about how we were supposed to present the CAD-CAM tutorial, the CAD-CAM work. I'm going to say it orally now. I'm going to send it as a notification later. I'm going to put it as a detail in the assignment box. For this one now we finished. That's it. That's the last G code we're going to write down and done. We can add the last sentence. We're going to be take the part and make the inspection and done. The part is ready. Okay, and what we done actually is what we call the expanded route sheet. In the route sheet, we mentioned, I'll show you details. We mentioned the operation number, what is the operation, details of the operation, and what machine we need to do. And sometimes, we're going to talk about this one in future lectures. We need to write down the expected time required to do the operation. And thus we will be able to calculate what will be the total time required to make one part. We can do something called design for the manufacturing. For example, we can modify the operation to reduce the time for the manufacturing, because every 10 seconds is going to accumulate it for more parts and it's going to work hours or days to manufacture the part. Okay, so, for the CAD-CAM, we have 3 parts. We sketch the 3 parts in the tutorial, and then we're going to do the solid cam for each one of them. You're going to select one of them to make a tutorial video for making the parts. Actually, I'm going to show you how what will be the best way to record the videos. For me, I found out that the best way to do that is adding this app to Chrome, which is called the numbers. Okay, the numbers. So the numbers actually you can go to the add-on and it's not the yes, you need to go to the setting and add the numbers. So the numbers NIMBUS.
So does it have to be the Kabi, or can we choose any part we want for that video?
Yeah. Well, if you have another app, use the other app.
No, I mean, does it have to be the carburetor part, or?
Oh no, that's up to you. Whatever the part is.
Okay.
Okay, but the carburetor part, because it's the easiest one, because I did it in front of you, so you can complete the same thing. The most important thing for this part, why I needed to be as a video, because in the old days, the student used to I asked them to use the snapshots and write the description below that. But I found that many of the students find a problem to do that. And I thought, okay, now why we train the student to make a presentation? This will be, you're again to do a presentation, your work in the future, definitely. So let's train you to do that. Now we work in remotely, so you will need to record these things. Some of the students say, okay, now I'm still not confident to do that in front of the others. So the videos are going to be unlisted. So just between you and me, you are going to make the video, save the video. You can download from the numbers and upload it to YouTube. Make it as private or make it as unlisted. Copy the link and put it in your work. for one of the three parts. For the other two parts, you're only going to do this the recording for the simulation part when the cutting tool is moving. And copy the link and put it on your assignment. Part number 1, 2, 3. Which one is going to? You will mention that this one is the full tutorial. Then 3 parts going to be you put them in a single folder. You compress it and upload it to the submission link for the CAD models. And randomly, again, to select as much as possible of the part and try to check the dimension against the A and the B, just to be sure that it shouldn't use their own drawings and they didn't share the other people's drawings. Okay, just be sure that when you do the solid cam, you put that in external, not internal. The other thing is for the carburetor part, I would like you to learn how to do the solder prop operation, which is the programming of the CMM machine. This will be a part of the lab report assignment. For the student who finished the part number 2, and they would like to machine it, so I will send you the procedure of preparing the code, and not next Monday, the Monday after, we will be able to go to the lab at the B4 Building 11, and we're going to have a demo for the CNC milling. And you will have the chance to submit your code, and we can machine the part number 2 by using the form, and you can take it with you. Okay, and what else do we have?
Also for the carburetor part, so do we need to worry about that hole that's coming from the side? So like the changing the geometry and putting the part on the side. Are we doing that? Or
The hole? No. I told you you don't need to do that. Don't worry about the hole, and don't worry about the cylindrical part above the hole, because you can do it, but it's going to take hours for the simulation. So don't do it. Just skip it. Okay. Okay. Yeah, for me, it took something about 30 minutes to complete the simulation for it. So just ignore it. Don't do it. I should remove it actually, or maybe if I get to do the subject later, I'm going to make it as straight. It's not going to be. I mean, the cross section is going to be square instead of circular or semicircular.
Oh, you mean cutting the half cylinder as well, or just the whole?
Just leave the half cylinder. Don't do it.
Okay.
Okay. And don't drill it, because the drill is required to have another setup, which is going to be on the side. Yeah.
All right.
Okay. Do we have any question today?
I have a question regarding the G code.
Yep.
We just follow the same procedure, but it's gonna be different for every student depending on their A and B.
Yeah, exactly. Yep.
Oh, okay.
Same procedure, but you have to find a new parameters. And once again, in my work here, I selected that the center of the work is the datum point. That's my selection. I did that because the work is symmetrical. And this make it easy. If you find the location of this point, the same thing is going to be on the other side, but you have to consider that the what the sign going to be for the X and the Y. Okay, that's why I choose the center, because of the symmetry of the part. Find one and you will be able to find all the other points directly. Mainly I did that for this shape and for the drilling of the holes.
When I did this part, my height was like 20 mil longer than the side. So I started with the rectangular, not the square, I think.
Wait, what? You got rectangular shape?
Yeah.
What?
So the side, from the side to side, is shorter than the height to height.
This one is 70 plus B. So this one is 70 plus B, 70 plus B. So all the same dimensions.
Yeah, but what I mean, the height from the extreme points, like in the vertical, it's longer than the horizontal. So if you inscribe it in a circle, right?
Yep.
So on the sides, you have a little bit of the circle left.
ask for control and show me that on the drawing. Show us on that on drawing, please.
Okay. I don't know if there is. Can you see it? So if I just offset it by 6 mil.
I got it. Yes. Oh, by the way, you shouldn't use the SolidWorks.
Yeah. No, I drew it before. Where is it? There it is. Just in case. So in my sketch, so because you inscribe it in a circle, right?
Yep.
You see that these sides are above the circle, and these sides are touching the circle. So this is 133, and this is 154. So it's not actually a square. So hexagonal is not a real square.
I start from square.
Yeah, I think it's.
I don't know. Anyway, just go ahead with the work. Don't worry about that.
Just want to point that out.
Okay.
Did you want us to find a particular stock material to start with?
No. Just say it's going to be aluminium and give any suggestion for the extra material that's going to be done by the machining. Removing you remember, we removed 1.5 from each side. It can be 1 millimeters, can be none. It's up to you.
Okay.
Let's just try to be more, what they call it, realistic. For example, what the standard we have. The standard we have, as I told you, the thickness can be start from 10, 15, 20, 25, 30. That's what the standard thickness for the aluminum blocks we can purchase.
Yeah, you mentioned that at the start. Okay.
Okay.
Sorry about the standard thickness. Okay. Do you have to manufacture it in that order?
The order I made.
Yeah, because
I didn't change the cutting tool between the operation, and this will be the best order.
Yeah. Okay. And
what the other suggestion you have? Because I like to listen to you.
Sure. If you had a machine that I see how if you're a machine you need to change the cutting tool by hand, that doesn't help, does it? I'd start with the holes and then have a little jig to put it into and then finish all the operations.
No. Don't start with the holes.
Yeah.
Sorry, everything you start with the holes. You cannot hold the part through the holes because when you do the machining, you will cut the nut's head, the bolt heads.
Nut head. I was thinking about using a cramp to hold it in place.
No, I think that device is going to be very good.
Okay.
Yep. That's what we're going to do in the CNC machining. You will see that in 2 weeks' time. Okay, in the lab.
Oh, so you wouldn't normally hold a whole part from just one side, like a chuck would. Like a chuck can hold the part.
Yeah. Well, actually, sometimes we're using the clamp, but the clamp is only if you would like to do the drilling of the holes. We can use the clamp. The vise is to do the face milling or the machining. We usually use the vise. And when you do the profiling, usually we use the bolts and nuts to fix it on table.
Yep.
So it's going to be free to move the cutting tool around the work.
Yeah, that makes sense.
Anyway, if you would like to have some extra marks, because actually I don't give full mark for this question. If you would like to have extra marks, you can discuss alternative operations or alternative sequence. It's up to you. You will add your task, so it's up to you. Okay. Now, any other questions?
Okay.
Just a general comment. I'm a bit lost with the material and what I'm supposed to be reading, and if there's any other books and things. So I went and grabbed.
Regarding the material you would like to use?
Yeah, like.
Just say aluminum block. That's it. You don't have to be that
Oh
specific.
no, I mean like just for study. Like I went to grab.
For studying.
Computer integrated design and manufacture. I grabbed that from the library, and then manufacturing engineering technology.
Yeah. No. Actually, the book you're talking about is quite advanced.
Yeah.
It's for specialized people.
Yeah, so, it only had like 6 pages on G coding though. So.
Yeah, I know. Well, that's a problem they have. Usually, what's happening that most of the books including the book we use as a textbook, like what's the name of the book? I forgot. It's by Groover. Okay, they don't focus on these things.
No.
They consider that this one need to be learned by the technician, not the engineers. But in my case, I think that the engineers need to learn that. Otherwise, they're not going to be able to discuss the issue with the machinist. They will tell them what he like to do, not what they're supposed to know. Well, actually, if you have your internship, have you done your internship yet?
No.
Okay, now when I did my first work, I went to the workshop and I found people who've been in the field for 20 years. And I had the theory, they had the experience. So they start to make fun of me because they start to ask me some questions about the practical issue. I don't know what to answer, and they start to laugh. And I waited. After 1 month, they had a problem cannot be solved because they didn't face it before. Then it came my part because I know the theory. So I solved it, and then I became at the higher rank than them. So the same thing will be happening to you. You need to understand all these things. You need to understand the CAD/CAM. Actually, I'm giving you this one because some of the jobs doesn't worth to do the CAD/CAM using the SolidWorks, or you don't have the software. So just simply write down the code and give it directly to the machine, or you can enter it manually and do the machining. That's why I'm focusing on this one. The other thing we're going to focus on is going to be the we did that actually in the lab. I told you the solder probe. I haven't done this one before. You're going to be the first probe. And we're going to do something with the robotic arm. We're going to do the robot studio. Most of the theoretical material is actually available in the lecture slide. Don't go outside at this level. Maybe if you're going to do your master degree, then you can search for the higher level material. Okay. Okay, now what else? Do you know what the Industry 4 is?
Say again?
The Industry 4?
Industry like 4.0, new manufacturing techniques and things.
Yeah.
Yeah.
So what do you know? What do you know about it?
Nothing. Just like new problems and new ways of solving problems with new technology.
Now, actually, the concept is going to be like something like interneting the things. That's what they're calling interneting of the thing, or IoT.
Internet.
So it's still a concept, by the way, because most of the other things already been done earlier. When we start to do the robotics and the automation with the robotics, and we start to have what we call the manufacturing cells or the flexible manufacturing system, and the CIM, which is computer integrated manufacturing, done. This is the Industry 4. The only difference is they try to link all the factories using the internet. So when you're going to have a certain design, you will check the list of the people, the factories, and what the machine they have. You should have an experience with the manufacturing. So you will say, okay, now those people having all the machines, and you start to contact them, multiple people, and you will choose the person who's going to give you the best price. You use his facility. So you're not going to give them the model and they're going to manufacture it for you. You are going to manufacture it by yourself, but using their facilities remotely. So the factory can be in China, it can be in Japan, it can be in Brazil, and you send the code to their machines. They only have to put the material required. So it's something like material handling. Then the machine is going to load it. The robot arm is going to load to the machine, do the manufacturing process. The inspection can be done by using the vision method, the cameras. Okay, and then it's going to do the packing. When you finish the whole batch manufacturing, they will pack it and send it to you. So it's something like Uber, but for factories. That's we are going to have a short session about it at the end of the semester, but this is the simple definition of the Industry 4.
Yeah, okay. I sort of get your point because with CAD modeling, you've gone from drafting with a whole team of drafters to CAD modeling in 3D with just one person taking over the job that used to be like a whole room full of drafting people.
Exactly.
Draftsmen.
Yep.
Yeah. Okay. So
And
that's
actually one PC today can take all the engineering drawings for all the products has been designed since the Industrial Revolution till today. 200 years of products engineering drawings can be now fit on your personal PC. If you're going to do them as engineering drawings using the SolidWorks. Yep. Okay, so that's it for today. We spent something about 2 hours. I still have another tutorial with my actually nephew. He's doing a project and he needs my help. So I'm going to leave you now. And if you have any question, come back to me later. I'm going to upload this recording whenever it's going to be available to YouTube and the Bilibili. I'm going to send you the link by using the UTS online. Okay.
Yeah, thanks.
Have a good night.
Thanks, Emily. Bye.
Thank you. Bye.
Thank you.
Thank you.